I'm going to be going through a definition of what engineers do and talk about some engineering disciplines. I'm going to be using Paul Copeland's Engineering Studies, the Definitive Guide a little bit in this video. But to get started, what is an engineer? Well, Wikipedia, they have a definition, and the word comes from the Latin word for cleverness. And I thought this was interesting when I was learning to say that I was an engineer in French, that I would say I was a génie civil, which is I'm a civil genius. And I always thought that sounded a bit odd, but it does come from the same word. And the origin comes from the word for siege engine. So catapults and things like that, trebuchets, they were built by someone who built those things, an engineer, and that's where you get the Army Corps of Engineers. And that then developed into military engineers and then civilian engineers, who I've heard the definition that mechanical engineers build weapons and civil engineers build targets, as an interesting way of thinking about that. So I won't go too much into engineering history because it's not really the focus of the course. I just thought that was an interesting thing. They do give a definition here. I think that's a little, I want to say, highfalutin for us. So I'm going to go with mine, which even mine is a little bit complicated, but we'll see what I've written here. So I have said, an engineer applies science and mathematics to develop products, processes, or structures based on forecast condition and behaviors for the maximum benefit of stakeholders. So let's go through that bit by bit. An engineer is a person, and they work fundamentally with maths and science. What they do is they make products, processes, and structures. Structures probably didn't need to be there specifically, but I've included that because I think it's fairly important. Like, it's a standout exception. But the idea is that they make stuff, and they make stuff using science and maths as the basis of how they chose to make that stuff. Now, they also make their decisions based on forecasts or predictions of conditions and behaviors. So, for instance, if I was thinking about, say, building a shelter on Survivor, well, I would have to forecast the weather, if it's going to rain or if it's going to be windy. And I also have to forecast the behavior of the things I'm making that out of. So if I'm using timber, or if I'm going to lower a friend down on a rope, well, I have to predict, I have to forecast the behavior of that vine rope and whether or not it's going to be able to hold my friend.
Why would you need a rope when building something?
Just using that as an example, I was thinking about the movie we watched where someone made a rope, and they were talking about how the light person had to go because they used their understanding of science and mathematics to predict whether or not the rope would be able to hold. And they do this for the maximum benefit of stakeholders. Now, if you have a look back on this definition, they talk about economics and safety and function, and those are definitely good considerations. But I always thought that it was very important when I was an engineer that we always used to talk about value for money or value engineering. And the idea is that often an engineer will choose a solution which is not the cheapest of all solutions. It's the cheapest solution in the long run, or it's the solution that gives us the most benefits for what we're doing. And the idea there is that I often say that anyone could build a bridge, but it takes an engineer to build a bridge safely and cheaply. That they can build a bridge so that we can afford, instead of having just one bridge, we can have two bridges with the same amount of time and effort and money. And the idea that we can build things, we only have to build them once rather than having to build them twice, so that the thing doesn't fall down. So that's where I would say, I think that's a working definition that you can use. I think that in every consideration I can think of, engineers have to use maths and science. An engineer always produces something. So it doesn't necessarily have to be a physical thing that you can pick up and touch. They could, for instance, an environmental engineer, they often produce things that are non-tangible. They might produce a clean environment, a clean waterway, a clean ecosystem, for instance. An engineer always has to make predictions based on conditions and on the materials that they're going to use and the processes that they're going to use, and that they always are looking to see who's going to benefit and how we can get the most benefit for the people that we're designing this thing for. Now, stakeholders doesn't just mean clients. It doesn't just mean the people who are paying for it. It doesn't just mean users. It could also mean the neighboring people. It could mean the wildlife that it has to interact with that design product. Okay, so that's a pretty long and drawn out explanation. And so then I have Engineers Australia colleges. Well, okay, first of all, what's Engineers Australia? Engineers Australia is the organisation that governs engineering in Australia. It's kind of in the name. The idea is that if you get an engineering degree, it has to come from for it to be recognised, it has to come from a university that is endorsed by Engineers Australia. Engineers who are coming from overseas who want to get their degree recognised, they have to apply through Engineers Australia. There's also a process of chartership. So becoming chartered is a sort of the final step of becoming an engineer. It's not compulsory in Australia, but it's generally for people who are going to start their own practice will become chartered. I am okay. So here we can see that I've got seven disciplines or 7 colleges that I use in my teaching. Now you'll notice that I don't include management and leadership, and I kind of roll in structural. Even though I had aspirations for structural, I did a lot of structural work, but I kind of roll that into civil because I think that's representative, and we'll see why I do that in a second. Now, it's important to say that engineering is a very broad field, and that a lot of people who start off in engineering often go into other roles. I remember when I graduated, there was a careers fair where they had coloured stickers to say, we hire people with this degree. And pretty much, I would say 95% of all the stalls had the red engineering sticker on it because I remember talking to Suncorp, and I would be honest, at the time I didn't know what Suncorp did. They're a bank, but I only knew that they sponsored the stadium up in Brisbane.
And it was sunscreen.
No, Suncorp's a bank. And I asked them what Suncorp did, and they said, oh, we're a bank. And I said, well, why do you want to hire engineers? And they said, well, because engineers have demonstrated that they can survive a difficult degree and they can apply maths and science in a rigorous way, and that's a skill set that pretty much everyone wants to have. So often engineers can move out of engineering into management, and it's a pretty great foundational course. A lot of my friends who I went to uni with, they're now in things that I would say doesn't really require the science background they had to do what they do. So for instance, a friend of mine's in procurement, which means that he just buys all the stuff that the engineers need. Whereas another friend of mine, Disco, he is a construction lawyer effectively, and he still is related. He's still working in the construction industry, but he's really working more on a technical management side these days. Okay, so let's get to it. Some of these I'll kind of go in alphabetical order, and some of these I will go through in sort of historical order. So to start off with, we're not getting to that yet. Don't get too excited. We're going to start with this one. I just want it to be that way. Okay, so engineering disciplines. So what are the engineering disciplines? Well, we saw them listed before, but we'll go through them again. So we've got biomedical. Biomedical engineers, they design stuff that is related to the medical field. That seems, I think it's kind of, it's in the name, but we're going to obviously go through in a lot more detail. Chemical engineers, that's a bit broader. So chemical engineers, now, these are my definitions. So there will be a lot of people who would disagree with these, but I would say that you could be a chemical engineer who specializes, for instance, you could be a materials engineer, and you could be a specialist in plastics or ceramics or nuclear or petrochemical. These are all different sub-disciplines within chemical engineering. A chemical engineer could work in, say, water sanitation. They could work in refineries. They could work in a whole bunch of different fields. Okay, so the next one is civil. Now you can see that I've coloured structural in the same colour as the others to say that structural in some places is considered a sub-discipline, and in other places it's considered standalone. So did my degree as a civil and structural degree, but I ended up only becoming chartered as a civil engineer. I didn't get my chartership for structural, at least not at the time that I applied. Maybe I could have gone into it at a later point. But there's transport, which is trains and cars and ports and airports. Hydrology and hydraulics is, but hydrology is the study of water. So you guys might know Mr. Carrotman. Yeah, that's what he does. Geotechnical is soil. Okay, so electrical. So electrical, they worry about generation, making electricity. They worry about transmission and distribution of electricity. That means getting the electricity from the power plant to you or to the user. They might be specialists who worry about renewables. So PV stands for photovoltaics, and that's solar. So UNSW is a University of New South Wales. They offer specialties just in solar cells. And then I have, like, just as an offhand one, overhead wiring. And so overhead wiring is for trains. That's how trains get their electricity. And that's a subdiscipline. I would actually argue that's more of a mechanical discipline, but it could be. The guy who I worked with most of the time, he was an overhead wiring electrical engineer. Okay. Then we have environmental. So environmental, they are mostly interested in protecting the environment. That's their main focus. Then we have ITEE engineers. So, I think I've said one too many E's. So information, telecommunications, and electronics engineers. So these could be software engineers. So software engineering is often called computer science at different unis. So this is a bit of a distinction we'll talk about when we get to that later, when we talk about fictional ones. But for the moment, we'll say that software engineering and computer science, they go very closely together. And we'll talk about the specific differences. So similar to chemists and chemical engineers, which we'll come to. Okay, network infrastructure. So this is things like signaling, and traffic lights. So the idea that signaling is for trains, they're the traffic lights that trains use. And controlling all of the tracks so that they move in time, that all has to be done by telecommunications engineers.
That's what WATNEY does, right?
That is. Well, she does control systems, which... one of the people just asked about my friend Renee, and I want to point out artificial intelligence is what AI stands for there. Some people call it AGI, artificial general intelligence, and we'll talk about that later. The next one, I have mechanical, and so within mechanical you have subdisciplines. So some people would consider these to be their own discipline, right? So aeronautical or aerospace. Nautical, so aeronautical is in the air, nautical is in the water. Mining, so some people would consider mining to be its own discipline, so I put that in its own colour. And mechatronics. And so mechatronics, I think of mechatronics as being something between a combination of mechanical, ITEE, and electrical. And so my friend Renee, she is a control systems engineer for the trains. So she doesn't worry so much about getting the lights to switch off and on. She programs the higher level thinking of why the lights would switch on, off and on. Yeah, the higher level. Okay, so we'll go through these and quickly. We'll give some definitions and then I'll go through roles and responsibilities in a second. Okay, so civil engineers. Civil engineers are... Well, I do have posters for this. How much effort is that going to be to find? It's probably going to be too much. Yep, we're just going to go through it. Civil engineers are responsible for the design and management of structures and infrastructure projects. So what do? Well, they design and they make structures, so buildings, and infrastructure. When we talk about infrastructure, we're talking about things like water supply, so dams, all the pipes that feed your house, and transport networks, so your roads, your rail, that sort of stuff. At this point, I'll say that the funny thing about engineers is when we talk about fictional engineers, we'll see how few fictional engineers there are compared to, say, fictional lawyers or fictional doctors. I would say there's probably somewhere between, I don't know, 20 and 100 times as many fictional doctors and fictional lawyers as there are fictional engineers. And I think a big part of that is because when you have an interaction with a doctor, I mean like a life-saving interaction. If you go see a cardiologist or an oncologist, someone who cures your heart disease or your cancer, you really feel as though that individual person has saved your life. Whereas the challenge I put to anyone listening to this is just try turning off the water to your house for just one day and see how much you appreciate the water when it's turned back on. Because I find it's the first time that you have to go, after you use the toilet and you go to wash your hands and you realize, oh, that water that I have, that I filled the bathtub up or whatever is not going to last as long as I might hope. And similarly, I say that I just think in other recordings I've made, I've talked about how I just think electricity is fantastic value. It's just such incredible value that it's worth 10 times what we pay for it. And if you just turn off the electricity for 1 or 2 days, you will really notice a difference. My kids, they really start to get upset when I make them turn off their devices for 1 day. So we really do take for granted. So civil engineers, they give us the clean water. Without them, without roads, if you have to start walking to work or walking to school every day, I think you would really suddenly learn what a huge importance they have in our lives. But we take them for granted because they're unseen heroes and unsung heroes. So without going too much through that, I will just mention that, like, for instance, books like Walden talk about living, off the grid. My brother loves off the grid videos. So that can, those sorts of experiences can sometimes help you appreciate, wow, this is what it's like to live without electricity. Okay, so mechanical engineering. Mechanical engineering, these engineers are responsible for the design, production, and operation of machines and mechanical processes. This ranges from making lunchboxes to the construction of cruise liners, to the operation of mines, to the launch of the ISS, the International Space Station. Okay, electrical engineers, they make and provide electricity. They design, construct, and operate electrical infrastructure such as generators, power plants, transmission lines. So transmission lines are the big lines, the giant ones that look like, I think they look a bit like people, like three-legged people. I really should have a picture. You know what? How much effort's that going to be? Application of transport, including trains and trams. Let's have a look. Transmission lines. Those ones. Yep. And substations. So substations are like houses for transformers. So this is a big substation, right? And you might see these locked up with a fence, in an empty lot near your house. And my children, their nana, my nana actually, she lives near a substation. But you might have a curbside one. New South Wales, they're green. There we go. Yeah, you might see something like this on a street somewhere near you. Maybe when you walk to school, you might see them. Okay, so let's go back to those slides. Okay, so we have chemical engineers. Generators, they transmit transmission lines, substations, trains and trams. We good?
Yes, can you go back to the other one? I missed one.
How about I'll go through it later. Yep. Okay. Chemical engineers design and implement processes that create or convert chemicals, their supporting infrastructure, and their application. So what do? They make chemicals and they allow us to get those chemicals, and then they use those chemicals. Now, the thing sometimes when people talk to me about chemicals is they say, well, water is a chemical, sugar is a chemical. everything is a chemical. The air we breathe is a chemical, but obviously in this case they make synthetic chemicals. They produce the chemicals we want. So this could be things like fertilizer that we want to use to grow our food, to petroleum, like to refining petroleum from crude oil. Yeah. Okay, so what do? They make production facilities and refineries. And they also work on networks like tankers and pipelines. So they might design a fuel tanker. Okay, we're good?
Yeah.
Okay. So I think this is the last one. This is the most recent. So ITEE engineers design, produce, and implement software, which is the code, hardware, which is the computing machines, the supporting infrastructure, so that could be the cables that go between them. So this ranges from programming to circuitry. So this could be they do the typing the program. They could design the silicon chips or the PCBs. They could work on signals and points motors. So we talked before about the trains, the things that move the trains are called points motors. And the communication networks, for example, the NBN. So someone has to build the thing that we use for the internet. I guess the thing I might write now is like 5G towers. So, okay, so that will do for the moment. Just to sort of break that up a little bit. So there is a worksheet that goes with that. Oh, I've still got two more. Okay. There we go. I thought I was up to the last one. Biomedical engineers responsible for the design and implementation of technologies and treatments for medical conditions. This ranges from artificial limbs, organs and joints, implants, scopes, scanners and monitors, treatments and delivery methods, surgical techniques, and assistive devices. So that's a lot of stuff there, but we'll talk about what they mean when we go into that in more detail. But I like to think of this as, so they do things like replacements, artificial limbs and organs and joints. So they replace things that aren't working in a way that we would like. So this could be a bionic ear, this could be an artificial arm, or it could be an artificial heart, something like that. That could also, goes into implants as well. They do diagnostic equipment, so scopes, so we can see inside you, or even like stethoscopes. Scanners, so we can see inside, like in MRI. Monitors, so things that keep track, the machines go beep, beep. Treatments and delivery. So treatment might be things like, radiotherapy is a treatment. So it's a way that we, so those doctors who save your life, well, they need modern tools to help do that. So they need the radiotherapy machine, and surgeons might use, we're going to learn about laparoscopic keyhole surgery. And then there's also assistive devices. So an assistive device could be anything from a cane or a crutch all the way up to a self-driving wheelchair or something like a assistive robot. Okay, and lastly, I've got environmental engineers. They're probably the most different, I feel, but that's why their sentence is different. And they're responsible for the design and implementation of technologies and treatments that protect ecosystems and communities. Okay, that first half. And then we'll go to roles and responsibilities later. Okay, so to break that up and make this a bit more interesting, I'm going to use some examples from engineers, just because otherwise there's really nowhere to stop. That kind of turtles all the way down. Okay, so engineers in fiction. Well, I've started off with Big Hero 6, and you'll notice that this particular picture doesn't have Fred in it because he's the only one who really doesn't seem to be an engineer. I know, scandalous, right? Anyway, so look, maybe he's something. I don't know. Okay, so to start off with, I guess going in alphabetical order here, I've got biomedical and mechatronics. So BAYMAX, he is a healthcare companion is what he is, and he can diagnose. He can tell when you're sick, and he can also help you. he can provide treatment. He is an assistive robot, so it means he can help other people to function better as well. Now, he is a biomedical, I would say, assistive device, but also because he's a robot, I would also say that goes into mechatronics, which I sometimes abbreviate here as MECX, which is pretty common. Okay. The next I have Honey Lemon. So Honey Lemon, I think, is in the Disney bio is listed as a chemist rather than a chemical engineer. So what is the difference? The difference is that generally a chemist is someone who finds new ways of doing things, and then a chemical engineer actually does that. So once you start putting things, if you're finding new solutions, that you're probably a chemist or scientist. Whereas if you're the person who actually gets it done so that people can benefit, who produces it at large quantities or helps the end user, then you're probably a chemical engineer. We'll talk more about that when I get to Breaking Bad, when I come back to chemistry. Okay, Wasabi is electrical and electronics. I think he's like a lasers expert. Gogo is a mechanical engineer. I think she's a specialist in electromagnetism. And then Hero, he is mechatronics. He is all about the robots. Okay, so getting back to chemical. So again, Spider-Man, I think, is usually shown as being a scientist rather than an engineer. I think that he's a chemist in that he develops new technologies and then he only produces them really for himself on a small scale. Whereas in Spider-Verse, which is easily the best version of Spider-Man that I've ever seen, the original, the TRN 700 Spider-Man, the blonde one, he at the end credits, he sings that he has a degree in chemical engineering. I think a master's, I don't know. Anyway, so Spider-Man, Walter White is probably the most famous chemist, I would say, fictional chemist at the moment. Now, I would say that he's an interesting example of someone who has crossed over from being a chemist to being a chemical engineer. So at the start of the show, he is someone who did research in chemistry, and he developed a new technique, and which, as far as the story goes, helped for his lab to get the Nobel Prize. But then later in the show, he starts producing his own chemicals, and he's producing a lot of those chemicals. He's not just producing a small amount, he's producing it in large quantities. And so that makes him I mean, maybe that's a bit of a spoiler. Okay, Bruce Banner is a nuclear engineer, and, well, maybe he's a nuclear scientist. I guess that's the distinction, but I just thought it was interesting to check out there. There are definitely nuclear engineers, the people who run nuclear power plants and nuclear reactors. They would be engineers rather than scientists. I think that Banner was probably a scientist. Anyway, but, you know, I snuck him in there. Okay, so civil engineers. This is mostly going in alphabetical with a couple of exceptions. So civil engineers, I've got a picture of TOPH. So TOPH is my favorite Avatar character. And she may not be an engineer, but I tell you, she would be a great engineer with the ability to know the composite of the soil around her. She would be an excellent geotechnical engineer, and I'm sure she would also she'd probably make a lot of money as a mining engineer. So her daughter, SUYIN, she is probably shown. She could go into a couple of camps, but I'm going to say that she's civil and structural because she designs a whole bunch of innovative buildings, and I would say that that would require a structural knowledge, but because those buildings, I think they move, that probably means there's probably a mechanical element to that as well. But I'm gonna put her in the civil camp because there aren't a whole lot of civil engineers in fiction.
Why are you not using the slideshow function?
I am, just the recording looks better on my one. So you're getting the bad recording. Okay, so this is Michael Scofield, and he was in Prison Break, and I think he would have been a great example 10 or 15 years ago because this show was really popular 10 or 15 years ago. This, I don't think this is a huge spoiler. I've never seen this show, but his brother goes to jail, and so to break him out, he gets a tattoo of the prison all over his body. And so he uses his knowledge of structure. His bio on Wikipedia says that he has a degree in civil engineering, but he works as a structural engineer. Okay, so in Atlas Shrugged, it really focuses on two engineers. It focuses on DAGNY, I don't know how to pronounce that, and she runs a railway. So I think she has a civil engineering degree. And Hank Rearden is shown as a metallurgist, which I guess would be a materials engineer or a chemical engineer. Danny is the protagonist of the book, so I'm focusing on her as the civil. Okay. Now, I'm not going to go into literally every engineer I can find. I left a couple out. I like Brad Pitt, and the fact that Brad Pitt was in. Someone once, when I was in high school, told me I looked like Brad Pitt, and I have now run that for my entire life. 20 years on, I still remember that, and I'm like, oh yeah. Now, I've had enough people tell me that was maybe not an accurate analysis, but I'm still sticking with it. Anyway, so he played a civil engineer in Mr. and Mrs. Smith, but it wasn't really, I don't think he was a practicing engineer. And there are a few other examples of this where we can talk about other engineers. Again, we're really short on civil engineers in fiction. So I'll talk in a second about some other examples that I have left off, but Jigsaw in the Saw movies, I think he is, if I look on the list of Wikipedia civil engineers, Jigsaw is one of the few they mention. So I also didn't include, in the movie Law Abiding Criminal, I think he's a mechanical engineer. Galen Erso in the Rogue One, he was probably an engineer, probably a structural engineer. Anthony Hopkins, he was in a movie called Fracture where he was an aeronautical engineer. They're the ones I can think of, but I mean, these really were not key plot points. You didn't see them be engineers in their movies, so I'm not focusing on it. It's also, while I'm talking about villains, it does seem that engineers do tend to be more likely to be villains than doctors or lawyers do. Like Batman, I mean, he's a lawyer. Yeah, Batman's a lawyer. Well, he has a law degree. I don't know if he passed the bar. But we never watched that first Batman movie because it wasn't very good. To pass the bar means to be like a practicing lawyer, to be a barrister. I don't know. That's an Americanism. Okay, so more often to be baddies, and Osama bin Laden, he happened to have a civil engineering degree. Probably, not really relevant to anything he did out in later life, but, I just thought it was an interesting bit of... Maybe. Oh, yeah, for Jigsaw? Yes, yeah, for Jigsaw. Okay. So, so when I asked some people, some of the responses I got were that Minecraft Steve and Alex, that they're kind of civil engineers because they make stuff. And they also mine, so mining engineering. I really didn't like the idea of Emmett, but I mean, he is shown as a construction worker. I mean, that's very different to being an engineer, but I don't know. These were recommendations. We're really, like I said, really clutching at straws for famous civil engineers. Okay, for electrical engineers, we've got Scott Lang, better known as Ant-Man. He's an electrical engineer. He didn't really do any electrical engineering. I guess it helped a little bit because he had to understand the science of PIM particles, but not a huge part of the movie. Is that the only electrical engineer I have? Oh man, I should have at least moved ASAMI up. We'll talk about that. I guess a lot of the other engineers I have as mechatronics. Okay, so for software, I have Neo and Trinity in the Matrix, which it shocks me how many students don't know the Matrix, which I appreciate it's a 20-year-old movie, but man, it was a huge movie when it came out. And I'm always astounded that how many people have not seen The Matrix, because it is really fantastic, worth checking out. The second and third movies, yep, you don't need to watch those, but the first one, definitely worth watching, especially if you like an action movie. Another recommendation I had was NAOMI from The Expanse, and she is a software engineer. So in Mr. Robot, he is a security software engineer, or a cybersecurity engineer, I think is his job title. So he's a programmer. And Felicity Smoke in Archer, not Archer, what's it called? Arrow. She is a software. Well, she has a. So I looked online, and so she has a computer science degree from MIT. So this would be the same thing. That generally speaking, a computer scientist is someone who develops new computer technologies. So they're people who are working in hardware, or they're developing new software, like they're developing a new system. Whereas someone who's putting that into practice and designing new solutions, they're working on computers every day at the end point, which is what I feel Felicity does in the episodes of Archer I've seen. I would say she's probably more likely to be a software engineer. But I have seen people who work at companies like Google talk about how even though different countries use different terminologies, that's the definitions that I'm using. So there are definitely people with computer science degrees who would say that their business cards would say that they were software engineers. Okay, I also have the movie Ex Machina. Like I said, I didn't want to try and add every. I'm not. Well, probably I'm getting close to listing every engineer I can think of, but Ex Machina is probably worth watching because it is a good example of the problems of mechatronics and very smart artificial intelligence. So it's a whole movie. I think these two are both shown as being software engineers, whereas the guy who builds the robots, he would be a mechatronics engineer. So I've got MechX there. Okay, so we're going to move on now to Enviro, and I don't think I have a heap. So I have Katara. Katara would probably be a great hydrology engineer or water systems engineer, but I put it down as environmental because I'm sure she'd be really good at cleaning waterways and rivers. And I don't want to give away anything from later episodes, but yeah, Katara from Avatar. Liet Kynes, this is from when I'm recording this, the upcoming Dune movie. Originally, Liet is written as a man in the books, but he is an ecologist, I think, but definitely an environmental engineering role. Okay, so moving on to mechanical. So I have probably the most famous, so MIT, which is a uni that really specializes in engineering, they claim Tony Stark as their most famous alumnus. So the most famous person to go to MIT. Fictional, that's a key detail there. Fictional person who's gone to MIT. So they're happy to claim him. He is, I think that when you look at what his degree he has, I think it's often stated that he has an electrical engineering degree and a physics degree, and that he got his engineering degree when he was like 17 or something, but like in 2 years. And it's definitely true that I would say that his arc reactor would be the biggest innovation in electricity since Ben Franklin. It's a pretty big deal, that arc reactor. The limitless clean energy would be a huge thing. The work that he does in developing Jarvis, just the AI interface that he produced, that would again, especially where Jarvis in later episodes, in later movies, what he ends up as, would be possibly the biggest thing in engineering ever. But we're going to focus on the Iron Man suit, which would be a feat of aeronautical engineering. A one-person flight suit that can travel faster than a jet. That's a pretty amazing piece of aeronautical engineering. And aerospace as well. I think he goes into space. So let's see. We're going on to The Martian. So in The Martian, in the book, he's described as someone who has a degree in mechanical engineering. He also talks about in the movie about being a botanist a lot. So it's often common for, what do they call them? People who go into space. Astronauts. Astronauts often have multiple degrees because there's only room for so many astronauts, so they really need to double up on skills. So you might have people who have done multiple things, especially if you have a colonist. Okay, and Benjamin Franklin Gates in what do they call these? National Treasure movies. He, I think, as a throwaway line, mentions that he also did mechanical engineering at MIT. Probably he shouldn't have made it onto the slides, but there we go. Okay, Scotty is probably the most famous engineer from the 20th century. Scotty is from Star Trek, and he is the engineer on Star Trek. I've said that he's probably mechanical because in the 60s, the idea of a spaceship was really more about fixing engines, and that was really what he focused on. And that's most of what he does is really sort of shown as being engine-based. In the TV show Firefly, KAYLEE is also, I'd say, mechanical. She fixes engines. She maybe could be a mechanic rather than mechanical engineer, but worth, there aren't that many, so I'm taking what I can get. Back to Avatar, and if I had realized that I only had one electrical engineer, I probably would have put ASAMI back there. But Masami is definitely shown as being more than an electrical engineer. She works on vehicles, so she works for her father's company, which they make the first cars in the Avatar universe. And later she goes on to build like robotic suits, which would definitely be an application of mechatronics. So mechatronics, like we said before, is a combination of... is it Sato, not SATA? Yeah, typo. I'll have to change that. Anyway, so yes, it's pointed out I probably have a misspelling in my my recording. Okay, and Varric, I'm pretty sure I spelt his name right because I checked it. So Varric, he in the second season of Korra, he is also a mechatronics engineer. Back to Star Trek. In the later Star Treks, so the Star Treks from the 90s, they, or I think Geordi's actually from the 80s, maybe better known these days from his appearances on Community. They really focus a lot on the computer side of their spaceships. So obviously they have engines, but those engines have a very big electrical interface. So Geordi, B'Elanna Torres, and Miles O'Brien is the person I'm ending on. And I'm ending on him because I think Miles O'Brien is probably a fairly big influence. I was a big fan of Deep Space Nine when I was a kid. I don't know if it's watchable now. I did try to watch it with my kids, and we did not get far. But big part of the reason why I went on to be an engineer, I think. So, I don't know if you've learnt much about engineering from looking at these fictional portrayals, but I thought it just gives you some context. So I just wanted to break this up because this gets pretty dry, so strap in. Okay, so all engineers design solutions to meet needs. All engineers do that. All engineers have to consider the social and cultural impacts of what they design. They have to consider health and safety. All engineers do some estimates or calculations. So that's where we talked about the forecasting and maths and science. They have to apply their knowledge of materials to design. All engineers consider environmental impacts. All engineers must plan and supervise. Well, not all engineers, but all engineering disciplines can be involved in planning and supervising, and generally almost all engineers do. And many manage maintenance and operations. So we often think of engineers as being designers, but often engineers are the people who keep things running smoothly. So it's one thing to design a road, but we also need people who maintain those roads to keep them operating. It's one thing to design a sewage treatment plant, but it's another thing for people to keep them running smoothly so that we can have, well, maybe it's a bad example, water supply. So we want to make sure that we keep getting that clean water, make sure that the electricity keeps, we keep getting electricity when we want it. Okay, so at the end of this, I will talk about engineering. Engineers Australia has a code of ethics that all chartered engineers need to be able to demonstrate, and they agree to uphold. But for the moment, let's continue on. So what I want to try and focus on here is that with these pages, you can see that the format is very similar, and the changes I've made in the colour for their discipline, just to make it easy to see what's happening. So if we go to civil, we can see, well, civil engineers, they design needs for infrastructure needs. So all engineers design for needs, But civil engineers, they worry about infrastructure. So we talked about that as being things like rail networks or water supply networks or just a building. It might be a house. It might be an apartment block. Okay, civil engineers calculate forces. So we'll learn more about forces as we go into the start of the course. But forces, so Copeland talks about in his book about, you might be familiar with Star Trek where you feel the force. Well, a force, we often define a force as a push or pull or a twist. And push or pull is probably the main ones. And when we think about, when I sit in a chair, my weight is a force exerting on the chair. It's pushing me down into the chair, my weight into the chair. And reacting against that, the forces of the chair, they want to hold together. And in order so we have the internal forces holding that chair together. So what we want to do is we want to estimate the forces, how many people are going to sit, or how big is the person who's going to sit on this chair going to be. And then we use our knowledge of materials to see whether or not the structure can withstand that force. So we say, well, how heavy is the person going to be who sits on the chair? And then how strong does the chair need to be for it to not fail? And then the others are the same as before. Mechanical engineers, well, they worry about dynamic processes. Dynamic means moving. And I used to say that as a civil engineer, if it's moving, it's broken, was what I would say. Which is good. So they also worry about forces, and they also worry about materials, but they do materials not for infrastructures, but for instead for design plant or products. So plant is big, heavy machinery, and products could be the things like the lunch boxes or the pens that they use.
The Pentel Energels.
That's it, the Pentel Energels. Okay, electrical engineers, well, they design solutions related to electrical supply, and they calculate voltages or currents. When we do electricity, we'll learn that voltages is kind of not a term we use very often anymore. So anyway, currents might have been the better term, I guess because they use currents down below. And they use their knowledge of materials to design infrastructure to transmit those currents. Chemical engineers, well, they design solutions for chemical processes, production, storage, transport, and application. Yeah, that sense doesn't make a huge lot of sense, but I'm sticking with it. So they calculate production needs, so they figure out how much chemicals do we need, and ensure that we have enough. And they then use their knowledge of materials to design for production, transport, and application of chemical processes. Probably should say and their application, but anyway, I'm moving on. Okay, roles and responsibilities. ITE, so this is like information, telecommunications, and electronics engineers. They design solutions for hardware, software, and network needs. They calculate user needs. So they say, well, how big does the computer that need to be for their users? They design and produce software, and they produce networks to meet user needs. Do I not say hardware? Design and produce. Oh, they have hardware right at the top. Yeah, anyway. Okay. For biomedical engineers, they design solutions for the diagnosis and treatment of medical diagnosis and treatment. They calculate patient needs. They apply knowledge of materials and a knowledge of biology to design technologies to improve patient outcomes. Now, patient outcomes is a bit of a weasel word sometimes. So sometimes they say, death is a negative patient outcome. Well, the patient wouldn't have chosen to die, so it's a negative patient outcome. But in this case, it's, well, we want patients who go to hospital, we want them to leave, we want the end product to be that they're better than they left. Or as good as possible. And so that's what we're talking about when we say we want to improve patient outcomes. Maybe the patient might still be sick for a few days, but a few days is better than a few weeks, as an example. Or that as an example. They improve the chance that they're going to survive the surgery. Okay, environmental engineers, this is the most different. You can see this one doesn't follow this at all. Okay, so environmental engineers, they assess the impact of engineering works on ecosystems and communities. They apply their knowledge of materials, their byproducts, and ecosystems. So they know about materials, and they also know about the byproducts of making materials, and we also apply knowledge of ecosystems. Environmental engineers introduce controls to limit the damage to the environment, and they plan and monitor their implementation. So often an environmental engineer, their job might be just checking that the thing is done to the standard that it's supposed to be. Ordinarily I'd have questions, but seeing as I'm to today. Okay, so next what I'm going to do is I'll outline what I'm going to talk about in part 2, but I will do it as a separate recording. Okay, so in the next video, what I'm going to do, I can say, I'll make a note that I should make the spaces bigger. Oh, I just remember I didn't have Miles Dyson from Terminator. He was probably a software engineer. I'm supposed to say that when I talked about Felicity Smoke. But anyway, closing that, I don't need that. Okay, I said that I would talk about ethics, so I'll remember that. So I won't go into the details of it, but there's 4 principles that Engineers Australia requires. That engineers demonstrate integrity, basically that they don't take bribes, that they practice competency, which means that they only work in the area that they are trained to, and that they know how to, that they're confident in. They don't work outside their area of competency. That they practice leadership, and they promote sustainability. Leadership, I think, is fairly obvious. It means behaving in a fair and equitable way. So it means thinking about things like not being discriminatory, as an example, behaving honestly. Oh, I guess that's integrity. And then lastly is promoting sustainability, is acting in a way that minimizes the negative impacts to the environment. What I'm going to do in my next video is I'm going to go through a timeline of engineering innovations. So that's what I'm going to go through next. There's a short one in Copeland's book, 2 pages, and I have 80 that I'm going to talk about briefly.